Linear regression, a supervised continuous data predicting algorithm. Now let's understand what do these terms mean. So when I say supervised simply means that I'm telling the machine what it's supposed to predict. For example, say for instance I have a data set of ages and pension. So my ages and pension, right? So I could have ages say 25. So in this data, when I tell any machine that hey, I want to be able to predict the pension after I have given the age as an input, right? So when I tell the machine what it is supposed to predict, that is what we call a supervised algorithm. It is an algorithm which involves us telling the machine that this data, this is the very thing that needs to be predicted. Now, the next step is to understand what do we mean continuous data predicting. All the word continuous means here is that our data here, which is the ages and the pension, my ages and pension aren't either 1 or 91. My pension is not 0 or 100. That is not the case. It is data that lies in a range. My ages, for example, in this data set, it lies in the range between 25 and 91. My pension here lies in the range of 0 to 300. So when my data is not limited to a certain set of categories, and it can be any value in between a certain fixed range, that is what we call continuous data. As simple as that. Now returning to linear regression. Now imagine a graph. What's happening in this graph is that we, as in our, I'm going to just rewrite our example really quickly. So now if we were to make a graph, say for example of our age versus the pension here, this is my pension and this is my age. It tells us that for the ages 21, there's no pension. Age 31, there is also no pension. For the age of 78, point here is the age of 78, and here is the pension of 100. Now, if I take the age of 91 here, roughly, for the age 65, now you might notice now that these 3 points aren't exactly in a straight line. But the point of linear regression is to be able to draw a straight line on this graph such that when the model is to predict the pension values for some value of the age, that prediction point should be as close to this line as it can possibly be. The distance between the real values and the predicted values should be as close as they can possibly be to this line. This is what we call the best fit line. Now, how this algorithm proceeds is a 3-step process. Step 1. It finds the average value for both of these criterions. So it will. Now the next step is, now that we have found these values, that would be step 2. Now what is the step 2? Before we move to step 2, let us quickly brush up on how do we even make straight lines to begin with. Straight lines geometrically are represented by a very simple looking equation, that is y values are equal to the values of x multiplied by a value of m plus c. Now here y is the values on the y-axis and x is the values on the x-axis, M is a number, C is also a number. Now, how do we determine what M and C is when we are trying to draw this best fit line? So, in order to find this value of M, which we call the slope, we use a formula that looks a little something like this, in which what we do is that we take the individual values from each column here, we subtract that value from its average, and then we simply multiply them. Let me show you what it looks like. So here, for example, as you can see, my ages are 21, 31, 78, 91 and so on. So I'm quickly going to evaluate their average age and their average pension. Alright, with that said, our average age is 57 and our average pension is 155. Now, how do we find the slope value? Now, let's quickly brush up on what does the slope signify. The slope signifies simply that this line here, it makes a certain angle. Slope tells us what is the magnitude of this angle, how far in what direction is our line turning. That is simply what our slope represents. Anywho, now let me show you what it looks like. So yeah, so my slope here would start off with, we'll start with ages. So 21, that would be 21 minus 57.2 into 0 minus 155. So that's just 150 minus 155. This plus 31 minus 57.2. Task is simply that we take the whatever we were doing with the values for the age here, because so far right now we've been doing ages and the pension, right? Now in the denominator, it's going to be the value for the ages, ages minus average age squared. So that would be 21 minus 57.2 squared plus 31 minus 57.2 squared, and so on. Now this whole process can be represented in a form that looks a little something like this: age minus average age into pension minus average pension. Now this symbol here, this one, it simply signifies the sum of these values divided by the sum of age minus average age squared. This is the value for slope. Now moving on, that was step 2. Now so now we have the value of M. We just need to find the value of C. How do we find the value of C, you might ask? Well, this is going to be one of the most easiest steps in this entire process. Step 3, C is simply equal to minus 1 multiplied by the value of M that we would have obtained, then that multiplied with the average value of our age plus the average value of our pension. That gives us, for some arbitrary value of M, this is the value of C. With that done, now in order to plot this best fit line of ours, we have the value of M, which is our slope, we have the value of C that we have just evaluated. All we have to do, which is the final step of this entire algorithm, is to simply rewrite that since we were looking for the pension, so our predicted pension is equal to the slope multiplied by whatever age we pass in as an input and this value of C. Now this might look a little bit similar, and that is because our predicted pension here is the value of Y, that is equal to m into x plus c, where y is our predicted pension and our input age is x. And that's just really, that is all there is to it. Our algorithm uses this equation here in order to bring the predictions as close as it possibly can to the real values. With that said, let's implement this. In C,